So today we are going to convert this schematic into the PCB layout like this one. And today we will start from scratch. We will learn every step to convert this PCB layout into this schematic into PCB layout. Okay, so first we will go towards design tab and we will click this item convert schematic to PCB. But before we will check that our connections are right or not, then we will go to design tab and we will convert schematic to PCB. When we click it, then the process will happen and we have to select the width and height of the board and we will set it later. So click apply, and if we zoom out and drag here down, so we got to know that our components are placed here automatically. So first of all, this is the PCB toolbox, this is the layer box, and I will use all of the system and will let you know how to use them all. Okay, so these are the components. First of all, I will drag these component. Okay, I will select all of these component and drag from here to the PCB board size. Actually, the pink marker shows the boundary of the PC. Like if we convert into 2D view, so the the pink line identifies the border of the PCB. Okay, so now our 10% work is completed. As we know that this is the PCB board that which will be out when we make it through GLC PCB or some other services. So now we will wire it. Okay, we will wire it according to the given schematic. Okay, so first of all we have these lines. So these blue lines are called as nets. It means that this specific particular pin will be connected to this pin. Okay, uh, all the blue lines show the are called as nets, and they show that where the components will be connected. For instance, this line will be connected to this H1. Okay, so first of all we will arrange our PCB so that our final PCB product will be so small. Okay, so first of all I will do this, that I will rotate it, and I can rotate it by clicking one time R. So you can see here it rotates, and I drag it from here to the bottom. Okay, then this is the connector. Okay, the H1 connector, that is this, and we will place it on the right side of the PCB board and again rotate it by pressing R. Okay, this is the H2. These all components are from this schematic. There is no other element than from this schematic. You know that U1, U4, this H1, H2 are the same components here. You can see U1, H1, U3, all the details are given in each component datasheet. To check this, just convert on just click on it and you will see its all details. Okay, so now we are designing our PCB, so I will drag these components to their desired places. Okay, so this specific chip is so much small, but we will make its PCB. Okay, so now we have to set up our initial setup, and here again we will again rotate it two times so that our positive input and positive output are on the downside to it. As we see that the text here written on it hasn't rotated it, so we will click the text one time and two times press R to rotate. Okay, similarly we will also rotate this out two times so that it will be in right place. Okay, we will drag it from here. Okay, the in point This is basically input negative, this is basically input out. For instance, it is called ground, it is also ground. As we can see here that it is ground, so basically negative signs means that it is ground. Okay, so we will also place this input plus here we can also, these all are just for the aesthetics of the PCB layout, so we have to make them easy for someone who will build next. So for him it will be easier. Okay, so there goes the H1 connector and its label. Okay, so we are placing it here. Okay, to drag it, just click left click and hold the mouse here and there, and you can place it anywhere. Okay, so we will also rotate it so that the ground is on the above side. Here the positive is on the upside, we will 2 times R. So let's see this, that ground is on. Okay, now we will we have already, so we have already placed our elements at the time. Okay, so now here comes the micro, I think U1 is, if we go to the schematic, so U1 is actually a level converter which is actually a SMD. So SMD is a little bit difficult to make a PCB layout, but we will somehow manage to make it. Okay, so here we can see that the hole is 5 volt and this is ground. So we will just rename it. Okay, we will name it 5 volt. Okay, so that looks same. It was a silly mistake, I don't know why. Okay, so here we will write as ground. Okay, so now we will start to wire our components once we place them all together. Okay, so now our placement of components is fine. Okay, we will drag these borders of PCB. Okay, we will do it later. uh, Now our board looks like this if we convert it into 2D. Okay, so now you can see it shows in a systematic manner, they all are placed in a systematic manner. So now we will place this chip little bit here, and now we will start to wire. So there are two ways to wire. First is this line. If this is this is the uh, item, when we click this we can wire. And for the purpose of and how to wire, I will show you. You can simply uh, press W. You can simply press W. Here you can see the arrows are showing, and when we click left click, so it starts to make the wire. So in this way you can see the wire is created. And if we want to uh, change its size, for instance, we want to make it in 20 mil size, so we will press shift plus W. There the size opens. So if we want the size of 20 mil, we will just select this size, and you can see our size increases. And if we again select shift plus W and select 100 mil, so our size increases. Okay, so now for each components there are required sizes. Okay, so now we are going to start wiring our PCB. So first of all we will connect these headers to these blue lines. I told you earlier, this shows that this ground will be connected to this and all the other stuff. So we will press W and we will select that shift plus W to select our desired wire. For these basic tracks we usually use 20 mil size, and we will go onto the this hole and press our left click, and then we will move toward the h1 h1's hole and just press left click to finish it. You can see there's the blue line is gone, and and a track is situated here. So again we will press W on this wire, we will go to the this point, and this wire is, and third we want to connect this A into this hole, so we will again go that way. Okay, now I want to tell you something that we will uh, go here in design manager. Okay, click on nets, as these blue pins are nets, and unselect the ground button. This is because we will make our whole PCB layout ground at top and at bottom plate. We will do it later. For understanding, for now we will not connect the ground of all components, but we will just connect it at the end of our PCB when it is built. Okay, so now we will again select W and make a trace of here H2. Okay, now we can make 2 layer PCBs, but it's a small PCB, so we are not required to make it as big. Okay, so now we will connect this in to the pin is okay. So now we will make we will connect it. Okay, again by clicking W, and we can't go through these red lines as the circuit will be short, so we will move around the PCB. Okay, and one thing more, never make a 90-degree turn, as it will broke down when the PCB is fabricated. So make 2 turns to turn the wire. Okay, so here this piece is converted, and then we will connect this piece into this, as we know that the blue out is going to there. Okay, so now what we will do, we will do that we will connect this 5 volt into this, because in schematic the out plus is the out plus goes to the 5 volt. So we will just make a wire from here and stretch it toward the this, so this line is connected. Okay, now we can design our these points. So as we know they both are short, so we will short them internally. Okay, and make this pin, this pin is converted into this. So now we cannot, so you can see here that we can't go as much big trace here. Okay, so we will finish our red line here and change our wire size, and we will change our wire size to 10 mil. Okay, so in this way it will go toward the SMD components. And one thing more, you will go into design tab, select design rule, and we will select 0.25 to 0.152. It's just because and hit apply button here. Okay, the settings are changed now. If we can easily make this 6 mil line, otherwise it can show DRC errors when we click this line. Okay, so now we will complete our remaining. Okay, so now we will connect this DE to this. So as we can see that sorry, first we will connect this DI to this button. Okay, so we will again change our wire size 20 mil to, so we can easily, the current easily moves from this point and this point, and at that point we can easily short our wire. We will again change the size to I think 10 mil will be better option, so I'll just put it down here. And for next, we can't short DE to here because there are two lines here between. Okay, so what we will do, we will again change the line size. We will go around here to this place to short our wire. Okay, so we will move just along this. Sorry, I'll make again, it was a faulty line. So in that way we can go from here. As we can see, the net is labeling. Okay, so we can go to here. Okay, okay, now it's right. And as I said that this can't be connected to this because the line size is too big. So we will again hit shift plus W and change our size to 10 mil. Then we can easily connect it to this. Okay, so now 10 size is not working, so we will change it to 8 mil. Okay, oh yes, now it's shorted. Now it's the 5 volt. Okay, we have to connect this. Now we can't connect from this 5 volt to this because we have to short these downward wires here. So we will do a thing that we will uh, make a wire opening from here, change its size to 20 mil so that neither the current waste, and we will go all the way from here from the bottom, and we will go to here to make our PCB. Okay, so we will change again its size so it can't make any error. We'll select to 8 mil and let's go. Our above PCB is completed, and now we have to place all these components here. So we will start from right position. Okay, so again we will press W for the Y, and now for now we have to move from there to so we will select uh, I think 10 mil will be enough. So we will go between the hole to manage our space. Okay, so this portion will be deleted and we will make it again as it was somehow not work. Okay, so now at this point we will again select 8 mil. Okay, and there goes our connection. Okay, now we will go again to the this point, select 12 mil from here so it can pass through these holes, and then we will go. Okay, so here's a twist that you should I can make from here. I can also draw a line that connects from this point to this point. That will be easy for me. I will select its size to 8 mil. Okay, then we will go to the paths here, and we will connect to this, and we can also go from such a start RPCB from the SMD size. We will move once we cross the size, so we can change our line size. Okay, so we will just drop down here and connect it. Okay, now it's okay. We will now connect this line, and we will move through. We can't pass through these holes, we can only move between these holes. Okay, so now as I told you that never make a 90-degree turn. Okay, so now we will again select this to 8 mil and complete our PCB. Okay, so now we have to short this into this, so we will internally short it. I think our PCB design, our PCB layout is completed. Only the oh, that remains. Okay, so we will just connect. I think that you have learned how to connect all these wires, because there are different techniques to join uh, the wires to each other. I am using the easiest way. uh, Once you are easy with the software, then you can make the lines by your own. If you want this, because this is the VCC pin, so you can also uh, set the wire size high, usually 20 mil. Okay, so now we can see only the grounds are empty, and we will make them at the end. So now it's the time, it's the time for board aesthetics. The customer wants to know that what is this point, what is this point, what is this point, what is this point. As we can show in PC that here we have labeled ground B A plus, and now we have completed this all these wires connection, but we haven't uh, told you that how the customer sees that this pin is ground. So we will now make the net labels. So for making these net labels, this is the top layer actually, uh, which we have made the wires. So we will move to the top silk layer. Basically the top silk layer, I will show you that if you convert into 3D, so you can see the text written, all the aesthetics of the board are made in on the top layer of board are made in this top silk layer. Okay, so now we will make the board aesthetics, so that it become easier for the user to find that which pin is this. So this is our circuit. Okay, so now we will just click on this ground, and we will plus control plus C for copying it, and then place the mouse here, and then we will select control plus V. So you can see the ground hits here. We will copy it 4 times for our desired, because we have 4 headers here. Okay, and for here also, and then we will also place the header pins here, and also for here, because these are, we will move the H2 sign little below the header, so it won't famous. Okay, so now we can see this pin is ground, so we will automatically leave it. So we can see that this pin is B, is connected to this, so we will change it into B. Okay, hit enter. This is A point, we will change to A, and this one is 12 volt, so we will provide this 12 volt. It shows that here we will connect the 12 volt voltage. So here the ground is already present, and here it is the 5 volt. So we will change ground to, will change ground to 5 volt. That are just aesthetics. We can write whatever we want, whatever we want we can write. Okay, so it's up to us that what we can write here. These are just board aesthetics. So other components are already labels, and you can see in this PCB, I have provided this PCB to you. You can see that uh, on the board, on the board's back side, the elements are also written. So now we'll make same elements at the board's back. In our board, our elements are only visible on the front side but not on the back side, so we will make it on the back side. uh, just like I told you that the aesthetics on the top silk layer are these yellow ones, and they only appear on the top side of the board. And to write on the back side of the board, we will go to the bottom silk layer. Okay, now we will do some such thing that we will just uh, copy all these wires. we will use we will use these wires again. Sorry, we will use these symbols again. Okay, so we'll just copy, we will just paste it back, and here you can see these are again in the top silk layer because we copied from top silk. We will go into their properties. These are the properties. This is showing that there is the layer. So we will select from top silk layer to bottom silk layer, as I told you that the bottom silk layer is the back side. So you can see the elements are inverted, and when we place them here and hit our 3D view, so when we go to the back side, you can see that all wait a minute, you can see all the elements are have gone to the back side. So we will just complete our remaining PCB. So we will also select all these grounds. Okay, then we'll paste them here. Okay, so we will just select these elements, we will copy them here. I don't know why aren't they being copied. Sorry, I can copy there from the from top plane, so it will be easy for me. Okay, once I copied these, I can make them from here. That's not a big deal. From here, the text, I will use the text button, and here we will place the ground. Again, here will be placed B, here will be placed A, here we will place ground. And now just we will just edit it. Here was B, so we will write B. There was A, so we will just rename it to A. There was plus 5 volt, so we will just put into plus volt. We will just copy this. Okay, and just place a text to it. Here, here, here in front of these top silk aesthetics. Okay, and we will just uh, paste them here. Okay, and we will rename these values to the values given on the left one. Okay, so RO, here will be when we double click it, we can rename it. We will press RE, here we will press DE. Okay, and at the last here will be DI. Okay, now if we go to the back of the board and just we will convert into this, so we can see that we have we can identify the pins from the back. Okay, now we have almost completed the 90% of our PCB. So we will just short the borders. To make our board short, we will just drag these here from the corners, and if required, we have to drag the edges. Okay, now the last step, we have to make the top plane and the bottom plane of ground. So for this purpose, we will go to the top layer, we will select top layer, and now we will select this button. Okay, copper area. When we select this, we have this. Okay, we will select this net to ground because we have to create all the ground plate of copper. We will select here, left click, and we will go all the way from this edge from to the this edge, and as the square completes, we will click right click, and you can see, boom, here are all top planes uh, board is gone to ground, so there are less chances for a short. This is a professional way to make PCBs, and like that we will go to the bottom plate. We will again select the copper area, net will be ground, and we will again go to top left edge, drag it to the top to the bottom left. We'll go to bottom right and till bottom up, and click and select right click, then boom, there are two grounds added at at the bottom and end the plate. And we will check design, click design and check DRC errors. So we are shown here that our some of our elements are not connected. I think why are these not connected? Okay, so we will check that where is the error. So we will again select the rule. Okay, so you can see we will just go to the design tab, hit design rule, and we will make it 0.100. Okay, so that it won't disturb us. Hit apply, click settings, and we will check DRC. So these are the errors showing, and it's okay. The error was showing that we haven't saved our file, so we will press Ctrl plus S, so you can see the file is saved. Now if we click design tab and check DRC errors, so there are no errors. It was just the error that we haven't saved our file. So now this is our PCB. Okay, now it's ready for fabrication on JLC PCB. If we look it from bottom side, so we can see all things are ready. If we check our 3D size, 3D in 3D, so it's a perfect piece. And now if we want to fabricate it on the JLC PCB, we will click fabrication, PCB fabrication. We will create a Gerber file, and we will check DRC errors. DRC errors are finished, and this is and now you can see that our board is ready to be fabricated with the help of JLC PCB, because our board has zero DRC errors, and it says that it is ready for the fabrication, and it takes $6.2 for 5 components of PCB. We can make it short because but this is the first time we have placed the big elements. We can place the shorter elements like SMD. I have created many designs. For example, I have created the ESP32, and I will show you anytime later. So this was our video in which we converted the schematic into the PCB board, and it is the ready to make the if we want to create the Gerber file, so we can directly click to you can say generate Gerber. If we generate Gerber, you can see this file is downloaded. If we place this file to any fabricating company, you can print you can fabricate your own PCB. So that was for today, that was the video, and I hope you liked it and got to know that how all this PCB stuff works. So thank you.